So in this video we'll be talking about summation notation. Summations look quite intimidating at first, but it's a great example of how simply just understanding what the notation means can help you an awful lot. So suppose I've got a bunch of numbers x1, x2, x3 all the way up to xn. So notice that I've got a total of n numbers, and these could be any numbers in the world. So what's the sum of these numbers? How would you find the sum of these numbers? Well, the sum would just be written as something like x1 plus x2 plus x3 plus x4, and you'd keep doing that until you got to xn. So that's the sum of these numbers. But what I want to know is there a shorter, more compact way of writing this, instead of having to write out this long, tedious line of text? Well, it turns out there is, and here's what I do. I'm going to write a capital sigma. So this is a Greek letter, capital sigma, and I'm also going to define an index. So the index we start from determines what the first term of our sum is going to be. So let's say that I equals 1. Let's draw an actual I. Let's say that I equals 1 is our starting index. I'm then going to define my stopping point on the top. So let's say the point at which I stop is n. And I'm going to sum over x of I. So what does this notation actually mean? Well, let me show you. So here's what I do. First, I plug in I equals 1 into my sum. So if I plug in I equals 1 to this, I get x1. Now I increase this index by 1 and plug in I equals 2. Well, x of I when I equals 2 is just x2. Again, now I plug in I equals 3 to get x3, I equals 4 to get x4, and I keep doing this until I get to n. So my last term is going to be x of n. And that's really all there is to it. It's just a more convenient way of writing the same thing. So that's what I mean by summation notation. I now want to look at some examples. So let's look at some examples. So the first one says we've got a sum I from I goes from 1 to n. And remember, just as before, we just plug in our values of I going from 1 to n, and we increase I one at a time until we get to this stopping term, which is 10. So when I equals 1, we've got 1. When I equals 2, this is just 2. When I equals 3, this is just 3. And I keep doing this until I get to 10. So I can keep going and say 4 plus 5 plus 6 plus 7 plus I equals 8 plus I equals 9 plus I equals 10. And you notice that when I do this, I'm basically just substituting in the values of I. So this would correspond to I equals 1. This would correspond to I equals 2, this would correspond to I equals 7, and this would correspond to our last term, I equals 10. So that's what this summation notation means. Let's do a slightly trickier example. What is the sum from k equals 2 to 5 of k squared? I've changed the lettering here. I've used k instead of I, but really you could use any letter you like. So, well, my starting term is 2, so I've got to plug in k equals 2 into my sum. My sum is k squared. That's the thing I'm summing over. So when I plug in k equals 2, I get 2 squared. Now I've got to plug in k equals 3, which is just 3 squared. I now have to plug in k equals 4, which is 4 squared. And now I've reached my last term, which is 5. So that's plus 5 squared. So that's what that sum means. Let's look at another example. How would I write the sum of 1 over n as n goes from 1 to k? Well, here's what I do. I plug in n equals 1, so I've got 1 over 1. Now for n equals 2, that's just 1 over 2. N equals 3 is just 1 over 3. And I keep doing this until I get to k, whatever the value of k might be. K could be 10, k could be 100, k could even be, well, we can actually have an infinite sum, but in this video I just want to talk about finite sums. So this sum just becomes 1 over 1 plus 1 over 2 plus 1 over 3 plus everything else up to 1 over k.